Okay, this is going to be quite a short video. The parametric using binomial expansion with partial fractions. The partial fractions can actually be used to create a nice pattern that we can then use to expand. The sort of thing they might ask us for is to expand to find the x cubed term for the expression on the left. So we might be asked to expand this function to x cubed and state the valued approximation. So by using partial fractions, you can expand this out. This is one of our examples from the week, I think it was like the 16th of November, and we went through this expansion. So what we can do is now we have two expressions that we can deal with separately. And it helps if you can organise a little bit. So I want to have 4x minus 3 to the minus 1. And the first thing to do is rearrange this into that form. So I'm going to rearrange, so I've got 4 over minus 3, 1 minus x over 3 to minus 1. So you should be familiar with that from the last exercise. We've now got it in the form that we can expand, and we want to expand to an x cubed term. So remember 4/3 comes out with 4/3 in front, and we start with our copying forward from the previous. So I've got 1 minus 1 x over 3, because remember the x here is 1/3, is x over 3 negative, so you need to change that to a positive 1/3. We've got a negative 1 from here, so n was negative 1. Just change the colour of the pen. So n is a negative 1, and my x is a minus x over 3 in this part. Go for the next term, and it's plus minus 1 times minus 2 x squared. So we've got 1 over 2 factorial. The x squared is going to be x squared over 9, and the minus disappears in this case. The 2 factorial cancels. Again, we've got n minus 1, 1 over 2 factorial, and we've got our x squared here, which goes to that. And we need one more term, the x cubed. So plus minus 1 minus 2 times minus 3 times 1 over 3 factorial minus x cubed over 27. And this continues forever. Okay. A couple of things to notice. First of all, let's do the cancellation in this one. So we've got positive again, so let's simplify it to minus 4 over 3, 1 plus x over 3. The 2's cancel, so it's going to be minuses cancel, so we've got x squared over 9. And the next one, the 3 and the 2 both cancel there. The minuses all cancel, so we've got x cubed over 27. This continues. And I'm going to consider the range of values. What we're saying is the modulus of minus x over 3, that passed my bracket, must be less than 1, which means that x is valid less than 3. Now we do the same thing for this second term. So that's 2x plus 1 to the minus 1. That's equal to 2. Rearrange it. It's nicely in our form already. Just need to turn the numbers round. Now it's equal to 2. Plot my numbers in. So we've got 1 plus 1 minus x. We've got minus 1 times minus 2 is plus 2 over 2 is 1 x squared. It's going to be x squared. Okay. I'll work that for got a minus x. And that one. It's 2 over 2, that's a 1 x squared. And we've got minus 6 over 6 x cubed. We need to consider what values is this value for. So modulus of x must be less than 1. So what this means for our domain is we're saying that on our number line 0. We'll only find that between minus 1 and 1, because the minus 3 to 3 range would give us invalid second terms. So if we use the 3's here, this would invalidate these terms, which would make them impossible to use. And the last part would be to actually expand these out and combine your terms. So we need to add the two together. So we've got minus 4 over 3, minus 4 over 9, x minus 4x squared over 27, minus 4x cubed over 81. Continues in the same way. And underneath it we've got 2 minus 2x plus 2x squared minus 2x cubed. All continues together, and we need to simplify these together for a final solution. So we can add those two together. It's going to give me 2/3. Now it's 18 minus 22 over 9. Oops. We've got 54 minus 4, so it's going to be plus 50 x squared over 27 and minus 162, 166 over 81 x cubed. So we've done the expansion, and this is valid only if x is less than 1, the smaller of my two domains.